Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adham bin Mumaris, number metric 1212727. Today, our group going to present Mathematics of Finance, which is consists of Muhammad Amin, Danish Daniel, Fatihul Naim, Shabil Irfan, and Rizwan. So, take a look of our group member pictures. This is our group member pictures. So this is our table of content. First, we are going to discuss compound interest. Second, present value. Third, interest compounded continuously. Fourth, amortization of loan. And lastly, annuities, which is consists of ordinary annuity and annuity due. So this is our first topic of the presentation, compound amount of compound interest. What is the definition? For an original principle of P gives the compound amount S at the end of n interest periods at the predict rate of R. This is the formula, S equal P 1 plus R to the power of n. So this is the equation. Suppose that Azhar has 700 ringgit in her saving account. This should be the principal value, P. After 3 years, the account amounted to 825 ringgit and 67 cents. This should be the S value, future value. If the interest was compounded annually, find the nominal rate of interest compounded annually that was earned by the money. So we have to find the nominal rate of interest. This is the solution. S 825.67. We have to find the capital I, which is the nominal rate lah. I equal to 1 because annually, T 3 because after 3 years. So we substitute in this formula. We got the R value and we use this formula to find the capital I, which is nominal rate. We got 6%. So this is effective rate of compound interest. The formula given is R equal 1 plus capital I divided by I to the power of I minus 1. The question is, find the effective rate if Ryan would like to make an investment of money at 8% compounded weekly. So we know that weekly we must calculate 52 because it is weekly. This is the solution. Capital I 8%, we convert to decimal places, we got 0.08. I, which is the how many times it is compounded, so weekly 52. So we use this formula and we substitute the amount and we got 0.083. That is the effective rate.
Assalamualaikum. My name is Muhammad Amin Arzukulu. My metric number is 1192846, and today I want to explain about present value. Present value, the principal P that must be invested the periodic rate of R for n interest periods to earn to component amount S. Formula is P equal to S 1 plus R power of negative n. Okay, this we have example. Aziz would like to earn $2,000 after 4 years. What is the present amount he should save now to earn the stated amount if the interest rate is 7% component monthly? This is solution. S equal to 2000 R equal to 0.07 and 12 multiplied 4 is 48. P equal to 2001 plus 0.07 power of negative, it will be $77.73. Therefore, to earn $2,000 after 4 years, Aziz should save 77.73 now. Thank you.
My name is Muhammad Fatuh Naim bin Henry Kasumal. My number matric is 1212753. So, what is interest compounded continuously? Interest compounded continuously have two subchapters, which is continuous compound amount and continuous present value. So the definition for the continuous compound amount is the compound amount S of a principal P after T years at an annual interest rate are compounded continuously. So for the formula is S equal to PE to the power of RT. The sample question is an amount of RM 45,600 is deposited in a bank paying an annual rate interest of 2.1% compounded continuously. Find the balance after 4 years. So the solution is the principal is 45,600. The T or the year is 4 years and the rate is 0.021. And if we insert all of this information into the formula, we get the answer RM 49,595.88 cent. Second, the continuous present value. So what is continuous present value? Continuous present value is the present value P of a compound amount S due at the end of T years at an annual rate of R compounded continuously. So for the formula, P equal to SE to the power of negative RT. The sample question is a trust fund for a 11 years old child is being set up by a single payment so that at age 21, the child will receive 14,000. Find how much the payment is if an interest rate of 7% compounded continuously is assumed. So for the solution, we get the compounded amount RM 40,000 and the T is 10 years because it takes 10 years from 11 years old to 21 years old, and the rate is 0.07. And if we insert all of this information into the formula, we get the answer RM 19,893.41 cent.
Now let's move on to the next subtopic, which is annuities. Annuities could be defined as any finite sequence of payment made at the fixed periods of time of equal length over a given interval. There is two types of annuities, which is ordinary annuity and annuity due. Ordinary annuity could be defined as a payment made of the end of each period, such as wage or payment to the employee, while annuity due is a payment made at the beginning of each period, such as rent payment. Now, let's move on to the first type of ordinary annuity, which is present value. It could be defined as the present value A of an ordinary annuity of R per payment period of N periods or the interest rate of R per period. The formula is A equal to R times 1 minus open bracket 1 plus R close bracket the power of negative N over R. And the question is, if $45,000 is used to purchase an annuity consisting of equal payment at the end of each year for the year 6 years and the interest rate is 11% compounded annually, find the amount of each payment. So the solution is we need to change the A to the amount paid, which is 45,000, and R equals to the percentage or interest rate compound annually, and N is the total year of the each payment, and we would get 45,000 equals to R times 4.23054, and we minus 45,000 to that number and we would get RM 10,636.95, and that is our present value. Now let's move on to the second type, which is future value. It could be defined as the future value of S of an ordinary annuity of R per payment period of N periods at the interest rate of R per period. The formula is S equals to R times open bracket 1 plus R close bracket the power of N minus 1 over R. And the question is, find the future value of an annuity consisting of payment of RM 135 at the end of every 4 months for 6 years at the rate of 12% compound 3 times a year. And the solution is, first we need to change R to the amount of payment, which is 135, and also T to 6, which is 6 years, and I to 3, which is 3 times a year, and also R, which is you need to divide 0.12, which is the rate, over 3 equals to 0.04. And the last one, you need to find the N, which is how many times the payment is made, which is you need to times the year and the month, which is 6 years times 3 months, and the end result you will get S equals to 135 times 5.64541, and you will get the future value, which is RM 3462.30 cents.
My name is Muhammad Shabir Irfan bin Muhammad Sabri. My matrix number is 1212755. So now let's look into the second part for the annuity, which is the annuity due. In this part, we will discuss on two subchapter, which is the present value of an annuity due and the future value of an annuity due. So now let's look into the first part, which is the present value of an annuity due. The definition of this subchapter is the present value A of an annuity due of R per payment period for n periods at the interest rate of R per period. The formula is A equals to R plus R 1 minus 1 plus R to the power of negative n minus 1 and divided by R. So the example question for this subchapter is the premiums on an insurance policy are RM 75 ringgit per quarter, payable at the beginning of each quarter. So the beginning here meaning that this is the annuity due. If the policyholder wishes to pay 1 year's premiums in advance, how much should be paid provided that the interest rate is 5% compounded quarterly? So the solution for this question is our R is 75 because RM 75 ringgit, and our I is 0.05 because the interest rate is 5%, and our I is 4 because compounded quarterly, and our T is 1 because 1 year. So our R here is 0.0125, and we insert all of this information into our formula, and we get the holder payment that must be paid is RM 294 ringgit and 49 cents. So now let's move into the second part, which is future value of an annuity due. The definition for this subchapter is the future value as of an annuity of R per payment period for n periods at the interest rate R per period. The formula is S equals to R 1 plus R to the power of n plus 1 minus 1 divided by R and minus R. The example question for the future value of an annuity due is at the beginning of each quarter, beginning here meaning this is the annuity due, RM 80 ringgit is deposited into a saving account that pays 4% compounded quarterly. Find the balance in the account at the end of the 6 years. The solution for this question is our R is 80 because RM 80 ringgit, our I is 0.04 because 4%, our I is 4 because compounded quarterly, and our T is 6 because 6 years, and our R here is 0.01. We insert all of this information in our formula, and we get the balance in the account at the end of the 6 years is RM 2,179 ringgit and 46 cents.
Now, let's look to the last part, which is amortization of loan. First of all, definition. A loan is amortized when part of each payment is used to pay interest and the remaining part is used to reduce the outstanding principal. It means that a loan is amortized when they have two parts, which is interest and the remaining part. In real life, the bank can consider each payment as consisting of two parts. It's same as the I mentioned earlier. The first of all is interest on the outstanding loan, and the second part repayment of part of the loan. That's why this is called amortizing. About the formula of the amortization of loan, they have three formula. First of all, the formula of periodic payment. Second, total interest paid. And the third, principal outstanding at the beginning of cat period. So now let's look to the example of question. A person amortized a loan of 115,000 ringgit for a new home by obtaining a 20-year mortgage at the rate of 6.5% compounded monthly. The question asks, find first the monthly payment, second the total interest charge, and the third the principal remaining after 6 years. So let's look to the solution of this question. For the first question about the monthly payment, we use the formula of the periodic payment. So to use this formula, we need to find what's the amount of A, what's the amount of R, and what's the amount of N. A equal to 115,000 ringgit and R 0.065 divided by 12 to find a rate for the 1 month, and we can get the 0.00542 and N equal to 12 multiplied by 20 because the whole year have 12 months, and we can get 240. So after we get what's the amount of A, R, and N, we substitute this amount to the formula of periodic payment. So after calculates, we can get that R equal to 1,118.71 ringgit. The second question about total interest charge, we use the formula of total interest paid, which is equal to NR minus A. N equal to 240. R, the amount for the first question, which is equal to 1118.71 minus A, 150,000. So we can get that total interest charge equal to 118,490.40. For the last question, the principal remaining after 6 years, we use the formula principal outstanding. In this formula, we need to find the K term first. To find the K term, we need to multiply 12 by 6 equal to 72. But 72 equal to the amount that you have been paid. So, to find the remaining principal, we need to add 1 plus 72. So, equal to 73. So, after 6 years, the beginning of 73 period equal to the 123,163.52 ringgit. That's all from us about the mathematics of finance. We hope that doctor can understand that what we present to you and hopefully can get the good mark for this presentation. Thank you again and hopefully can see you doctor again. Bye.